Covalent bond. A covalent bond may also be termed a molecular bond. Covalent bonds form between two nonmetal atoms with identical or relatively close electronegativity values. This type of bond may also be found in other chemical species, such as radicals and macromolecules. The electron pairs that participate in a covalent bond are called bonding pairs or shared pairs. Typically, sharing bonding pairs allows each atom to achieve a stable outer electron shell, similar to that seen in noble gas atoms. Properties of covalent compounds. State. Depending on the nature, as well as amount of covalent bonds between atoms, covalent substances can exist in all three states of matter. Covalent compounds in the gaseous state are primarily held together by mild electrostatic forces, but those in the solid form are held together by stronger forces. H2O in a liquid state, CO2 in a gaseous state, as well as diamond in a solid state are all instances of covalent compounds in distinct states. Boiling and melting point. Because the boiling as well as melting points of covalent compounds are determined by the degree of attraction between the atoms or the strength of the bond, they are lower than those of ionic compounds. Electrical conductivity. Except for graphite, that is a good conductor of electricity, covalent compounds cannot conduct electricity under normal conditions. Covalent chemicals cannot transmit electricity in an aqueous or molten state because they do not produce ions. Directional nature. Covalent bonds are directional because some orbitals, which are oriented towards a specific axis, overlap. Strength of the bond is determined by the overlapping of the orbitals, therefore efficient overlapping results in stronger bonds. The direction of the created bond is determined by the orbitals involved in its formation. The s orbitals are symmetrical as well as can create covalent bonds in any direction, whereas the p orbitals are oriented along a certain axis as well as establish stable bonds in that direction. Because of the directed character of the bonds, different covalent compounds exhibit isomerism. Solubility. Nonpolar solvents dissolve covalent molecules that do not dissolve in polar solvents. Because of intermolecular hydrogen bonding with water molecules, some covalent compounds may dissolve in water. The lack of polarity of the bond causes insolubility of covalent compounds in polar liquids. Types of covalent bonds. Covalent bonds come in a variety of shapes as well as sizes. Depending on the quantity of covalent bonds in a chemical, multiple types of covalent bonds exist. The number of covalent bonds is also determined by how many electrons are shared. Single covalent bond. Single covalent bonds are created when the interacting atoms share a single pair of electrons. Compounds with single covalent bonds have a lower density, as well as the bonds are weaker, but more stable than those with multiple covalent bonds. In single covalent bonds, the length of the bond is the longest because two electrons hold the nucleus with less force. Single covalent bonds can be found in elements that are widely apart in the periodic table. The covalent bond between hydrogen, as well as chlorine atoms in hydrogen chloride is an example of a single covalent bond. Double covalent bond. Double covalent bonds are created when two pairs of electrons are shared by the atoms involved. A double covalent bond has a strength that is halfway between single as well as triple covalent bonds. In the same way, the bond length is shorter than a single covalent bond yet longer than a triple covalent link. A double covalent bond arises in elements having 4 or more electrons in their outermost orbit that are closer on the periodic table. Because the shared electrons have a higher reactivity, double bonds are frequently less stable than single bonds. The link between carbon, as well as oxygen atoms in CO2 is an example of a double covalent bond. Triple covalent bond. A triple covalent bond is created when 3 pairs of electrons are shared by the atoms involved. Triple covalent bonds are the strongest covalent bonds because 3 pairs of electrons hold the nuclei together. Because larger forces draw the links closer together, the bond length is the shortest. The triple covalent bond is the least stable because the increased electron density causes the bond to be more reactive. This form of connection happens between atoms of the same element or elements in the periodic table that are relatively near together. The bond between 2 nitrogen atoms in the N2 molecule is an example of a triple covalent bond. Polar covalent bonds. A polar covalent bond occurs when atoms are shared unequally in a covalent bond. Specifically, when the difference in electronegativities of the 2 atoms in the bond is between 0.4 and 1.7. The terms polar bond and polar covalent bond are generally used interchangeably. There is a bond between the atoms, and electrons are shared, but they are pulled more closely towards one of the atoms in the bond. The atom that pulls the electrons more closely has a slight negative charge, and the other atom has a slight positive charge in the opposite direction. These types of covalent bonds are present in many types of molecules, such as ammonia, water, and hydrogen fluoride. Nonpolar covalent bonds. Nonpolar covalent bonds are chemical bonds that share electrons equally between the 2 atoms in the bond. This equal sharing happens as a result of the similar electronegativities in the atoms participating in the bond. Here, the charge is distributed equally between the two atoms. Examples of nonpolar covalent bonds are H2 hydrogen gas, O2 oxygen gas, and F2 fluorine gas. Coordinate covalent bonds. A coordinate covalent bond is a chemical bond between two atoms in that a donor atom donates a lone pair of electrons as well as an acceptor atom accepts them. A coordinate covalent bond is a sort of covalent bond in that the bond is created by the sharing of electrons, but only by a single atom. The bond between the nitrogen, as well as hydrogen atoms in NH4 positive is an example of a coordinate covalent bond.